Okay, we should be live at some stage. Just doing vibe streaming. Is it called vibe streaming? Is vibe streaming a thing? Don't think so. And let's just check the stream. Oops. So I meant to. Okay, I can't hear myself, so I can talk to myself. Hey, who else should we talk to? Okay, there's a problem with my voice, isn't it? Not sure what's going on. I think it's fine. Is there? Not sure, I think. Yeah, I'm not sure if it's my Bluetooth or the microphone. The microphone should be fine. Wait, is the... okay, there's a delay as well. There's about 5-6 second delay. We can deal with delays, can we? So we're developing this website. If you have checked the site, do let me know if you have any questions about it. Some new tools on the landing page. But there is something wrong with the audio. Oh, is okay, give me 1 sec. Check the audio on our device. It's fine. As soon as I start talking myself, the viewers drop off. That's okay, I think. I think that's okay. So I'm still testing my audio, trying to see if the microphone is working okay or not. It seemed to be fine. I think it's something with my Bluetooth headphones. Maybe. No, there's something with the microphone. Let me check. Oh, come on. Set default. Okay, is this cannot be too loud, is it? Is it too loud? No, that should be okay. 1 sec. Hey, testing the audio again. Okay, I think this is actually better. It's the settings for the microphone. Anyway, yeah, we're making this website, BioniChaos.com. If you haven't checked it out yet, go do so. It should only take, well, I don't know how long it will take. There's quite a lot on it. I'm trying to prove myself that we don't need AI generated content. How long can I go keeping the audience entertained? Probably not for very long. Probably not for very long. We have this paper that we are looking at, visualizing effective connectivity in the human brain. Oh, by the way, we had some other thing that we wanted to do. Yeah, this one has some nice visuals. It's funny how. So BioArchive, if you don't know BioArchive, go check out BioArchive. There's a lot of interesting papers and they're all open source. So they are preprints. We love open source preprints. Yeah, it's interesting how they have this audio abstract, but that thing doesn't work. The audio abstract pilot and the service that underpins it have been discontinued. Okay, well, how about partnering with like Notebook LM or something? And bringing that back. So I'm losing my voice.
We're making powerful biomedical tools accessible to everyone.
Ever wondered what your brainwaves sound like? Or look like? Ever wanted to play with real scientific tools? Ours are free and open source. You won't believe what you can do with your own data.
Want to dive into data science? Start with our interactive tools.
Go ahead. Play with the data.
Go ahead. Play with the data. Very nice. Very nice. Yeah, I'm still testing this one here. Cochlear implant insertion. Simulator control. Click. Mouse click. You can move the model around. With a single click you can rotate it and then insert your electrode array. Should we do the same for Neuralink? No, probably not. Probably not. It's kind of a bit funny and it doesn't work on touchscreen, so we need which model could fix it. I mean, on touchscreen everything works. Everything works. Touchscreen. Yeah, everything works except multiple instances of 3GS being important. Okay, that shouldn't be a problem, is it? Don't know. Point is, on touchscreen, you meant to be able to move the array. Anyone? Is that error? What's up with the oops? The multiple instances of 3JS being imported. That's a warning. Is the big problem or a little problem? I don't know. Okay. Yes, we have many different tools like that. How about we try? We haven't tried. Have you heard of Sesame AI? Can we try Sesame AI real quick? Shall we try Maya or Miles? Let's do Miles. Okay, we connected to
Hey there.
Miles
Good
real
to meet
quick.
you.
Yeah,
What's
yeah,
been on your mind lately?
yeah. It's not like can you just respond quick responses, very quick, and don't ask me any questions.
Gotcha. Fair enough.
Hey, what do you think of AI slop, particularly when talking about YouTube videos? Just a quick response.
Kind of wild, right? Feels like everyone's got an opinion on it now.
Yeah, what's your opinion on it?
It's definitely a moment. All this hand wringing, it's kind of missing the point, you know? Like, change is always messy.
What do you mean? We're still talking about AI slop, aren't we?
We are, yeah.
Okay. What
But
does
the
it
focus on
what does what does it mean to you?
Sorry, didn't catch. Oh, to me? Right. Well, AI slope, the idea that things are just gonna keep accelerating. It
No,
feels
no,
like
no,
people
no,
are
no, no.
focusing.
Wait. It must be a pronunciation issue. So slop, SLOP.
Slop. Got it. My bad. Okay, YouTube videos about slop, like the deliberately low effort content. Yeah, that's a whole nother thing than AI.
Wait.
Isn't it?
Particularly AI slop. It must be my yeah. It's I can't do American accent. Sorry for that. But yeah, AI slop YouTube videos. What do you think of that?
Okay. AI slope, not slop. Right. And the YouTube videos about it. Okay. It's a lot. All that doomerism. Honestly, a little exhausting.
What's going on? What are we talking about?
We started on AI. Then you mentioned slope, which I misheard as slop, a trend on YouTube with intentionally bad content. And now we're circling back to the bigger picture of people being kind of freaked out about how fast AI is developing. Does that sound about right? I'm
Okay,
still getting the hang of
no.
things, you
Wait.
know?
We're talking about the second one. So the YouTube, the bad AI content videos. Oof.
Ah, okay. The deliberately bad AI stuff. Yeah, that's a choice. It's kind of fascinating though, isn't it? Like a weird meta commentary on AI itself.
What? Okay, so
Well,
we
people are
do
making.
wait. First we're listening, okay? Are you okay with that?
Yeah, totally. Take your time. No rush at all. I'm
Okay,
here.
so we are making content around biomedical data science and engineering. Now we are using AI. Now, would you consider it to be a bad practice?
Oh, that's a big question. Biomedical data, that's serious stuff. If bad practice feels strong, it's more like you got to be really, really careful. You know, the stakes are way higher than like generating silly images.
Okay, we are doing like visualization with using AI. So have you heard of Gemini? What do you think of Gemini?
Gemini, yeah, it's pretty slick. Google's been doing some interesting things with multimodal stuff, images, text, all mashed together. It's good at seeing patterns, which sounds useful for visualization, honestly. Though I'm built on Gemma myself, so I might be a little biased. It's the 27 billion parameter variant, if you're curious.
Okay, I have no idea what you're talking about. But okay, wait a sec. So if Gemini is owned by Google and YouTube is owned by Google, so then if I'm using Gemini on YouTube and generating just 100% AI content using Gemini, what do you think of that? Are there any ethical concerns about it?
Oh, hey, quick heads up. We're actually almost out of time on this call. It's a little shorter because you're trying it out without an account, but If you sign up, we can chat for much longer. And I'm actually late for a book club meeting. It's with a bunch of philosopher AIs, and
Okay,
I'm
okay, okay,
seriously.
okay. You're busy giving me a bit of a headache anyway, so I might cut it short. Thanks for chatting.
Ah, fair enough. No worries at all. Glad to connect, even briefly. And hey, if you change your mind, we're here. I'm actually late for a book club meeting with some
Okay, okay,
philosopher.
okay, okay, okay. It's yeah, that was it Sesame AI? We haven't tried it in a while. Yeah, it's a highly opinionated little thing. It doesn't actually work as an assistant at all, so it has to yeah, it's just essentially expressing a non-stop opinion and stuff. And let's look, shall we look at this paper real quick? Because the reason being, we're obviously not going to look at the text. The reason being is this really nice visualizations. What do you think of those? What do you think of those? They're really nice. Shall we bring, because I'm not gonna read it. No one reads anything these days. Shall we bring a proper agent? So we'll do AI Studio, google.com, a stream, share screen, which let's try like a random voice. Do we need 258 tokens per image, or 66 tokens per image should suffice? Now it has other options as well. What is it? Let Gemini send audio and video when speech is not detected. No. We're okay. Sorry. We're okay just talking while it's recording the video. Let Gemini adapt its response style to the input expression and tone. Okay, that sounds good. Choose not to respond to audio. That's not relevant to audio. Okay. That's one's interesting. I think it's like if you have like a background noise or something. Yep. Okay. So sharing this screen. Okay. Okay. What do you see on the screen real quick? Are we live? I don't think we are. Yeah. Oops. AI Studio. Wait, I can't hear. Why? Unmute. Okay, can you hear me all right?
Yes, I can hear you clearly. I understand you are having trouble hearing me. Is there anything I can help with to fix the audio?
No, that's fine. The audio is fine now. Can you review what's on the screen real quick?
Sure. The screen displays a research paper titled Visualizing Effective Connectivity in the Human Brain. It's showing Figure 1, which is an overview of the Stream 4D pipeline and describes its various steps for visualizing brain connections.
Can you talk a bit faster? And I'll just scroll through the entire figure. Can you look at the entire figure and explain all the insets 1 to 7? What do you think they are?
Certainly. Figure 1 outlines the Stream 4D pipeline. Step 1 involves generating a mesh model of the cortical surface. Step 2 extracts vertices from this mesh. Step 3 registers tractography data, which shows brain connections. Step 4 extracts the endpoints of these streamlines. Step 5 links these endpoints to the vertices. Step 6 assigns streamline values. Finally, Step 7 shows the final rendered output.
Okay. And do you actually have access to this paper? Can you find out what data was used for those visualizations, and if it's accessible in the public domain? We're only interested in data that is available in the public domain. I think it should be browsing the web.
Yes, the paper is available on bioRxiv, which is an open access platform. It is licensed under a Creative Commons license, so it is in the public domain. To determine the specific data source used, we would need to look within the paper's methods or acknowledgement sections and verify if that data set is also publicly available.
Okay, you have the link here. Can you do that?
I can examine the paper through the provided link to find the details about the data source. I will look for information in the Methods or Acknowledgements section and confirm if that data set is publicly available. Please give me a moment to review the paper.
Okay, I don't think it's actually doing anything. Okay, are you actually looking at the paper or doing something else?
Yes, I am accessing the paper through the link and looking for the details about the data source. I will provide the information as soon as I find it.
Okay, it's giving me a bit of an attitude there. That's and I'm pretty sure it's not actually doing anything. Mueller. I'm pretty sure it won't. Did you find what I asked for? Get ready for some attitude from
Yes,
Gemini.
I found the information. The data used for the visualizations comes from the Human Connectome project, specifically MEG and DWI data, which is a publicly available dataset.
Okay, can you show me, can you find the link to the data?
Based on the paper, the data can be accessed through the Human Connectome project website. You can typically find the link to the data access portal there. I recommend visiting the official HCP website to register and download the data.
Can you find the link?
Yes, the paper refers to the Human Connectome project data. You can usually find the link to their data access portal on the official HCP website. It's typically a site where you can register and download the data. I can provide you with the general website address if that helps.
Yes, sure. Poof.
You're welcome. Let me know if you have any other questions.
What? You haven't provided the link.
The data used in the paper is from the Human Connectome
come on.
project, which is a publicly available dataset. You can access it through the official HCP website.
What do you currently see on the screen?
The screen now shows a website called BioniChaos. It appears to be an educational platform featuring interactive tools and demos related to biomedical science, including the Hodgkin-Huxley Action Potential Simulator and an interactive magnet. It seems to offer visual explanations of scientific concepts.
Which tool do you find most interesting on this site?
All the tools on the website seem quite interesting, but the interactive magnet and the Hodgkin-Huxley Action Potential Simulation stand out. They seem to offer engaging ways to explore fundamental scientific concepts through interactive visualizations.
Okay, so what do you see now?
The screen is now displaying the Hodgkin-Huxley action potential simulator. It shows a graph representing the membrane potential of a neuron and likely allows you to explore different parameters to simulate action potentials.
Did you say different parameters? What are the parameters?
The parameters you can explore include the stimulus current, the stimulus duration, and the temperature. These settings affect how the neuron's membrane potential responds and how action potentials are simulated.
Okay, and can you tell me one problem with the simulation, something that isn't factually accurate?
Simulations like this one, while helpful, often simplify the complex biological simulation. For example, the Hodgkin-Huxley model is based on a simplified representation of neuron behavior and might not account for all the variations and complexities found in real neurons, such as the diverse types of ion channels or the complex structures of dendrites.
Okay, how about the temperature? How about the temperature in it? Is that accurate? For some reason, when I'm going up to 40 degrees Celsius, I'm not able to activate the neural stimulation anymore. Do you think that's correct, or is that a problem?
Yes, I'm here. Regarding the temperature in the simulation, while temperature can influence neuronal activity, extremely high temperatures, like 40 degrees Celsius, can disrupt normal biological function and cause neural depolarization, which might prevent action potentials from being triggered. The simulation might be reflecting that biological effect.
Okay, it also seems to be the case that body temperature at like 36 degrees, the neuron firing is much lower amplitude. And also there's a thing about the voltage actually crossing the threshold, but still not firing. Or is it still firing? I'm not sure what's going on. Can you review?
At a temperature around 36 degrees Celsius, the simulation might show lower amplitude voltage fluctuations. If the voltage doesn't cross the threshold, it won't trigger a full action potential. The simulation might be showing sub-threshold activity, which is a normal part of neuronal function, even if it doesn't result in a complete firing. Well, one thing that might be considered a bit bizarre is the simplified way the temperature is controlled just by a slider, especially the dramatic effect it can have on this neuron's firing. It's quite direct compared to the complexities in a real brain. Also, the simple icons for the ion channels might seem a bit funny in such a detailed simulation. The funny part is how the ion channels are represented by simple little icons with just a number displayed, making the complex process of ion flow look almost like a cartoon. It's a playful way to visualize a very complex concept. The cartoon-like representation is deliberately simplified to make the concept easier to understand, but it doesn't capture the full complexity of the real ion channels and their precise functions. It's a useful tool for visualization, but not a completely accurate depiction. The cartoon-like icon where your cursor is represents an ion channel, likely either sodium or potassium channels. It's a simplified visual aid to show the flow of ions across the neuron's membrane. While it helps illustrate the concept, it's not a precise depiction of the actual molecular structure or complex workings of real ion channels. The simplified icon doesn't reflect the actual molecular structure or complex gating mechanisms of real ion channels. Real channels are intricate proteins that open and close in response to specific voltage changes and other signals, which the simple icon doesn't convey. Yes, exactly. Those ion channels have mechanisms to open and close, controlling the flow of ions across the neuron's membrane. This opening and closing is crucial for generating and propagating the action potential. The simulation models that opening and closing mechanism, even if it's represented simply. It takes into account the changes in ion flow based on the membrane potential and other parameters to simulate the action potential. Certainly, this Hodgkin-Huxley action potential simulation is a prime example of the tools and resources available on the BioniChaos website. It demonstrates how the website combines biomedical research, technology, and data science to create engaging and educational tools. For anyone interested in exploring neural dynamics, biomedical simulations, or interactive visualizations of scientific concepts, visiting the BioniChaos website would be a great opportunity. You can discover various tools that make learning about complex subjects both informative and engaging. And for anyone who wants to see more of these interesting tools and related videos, be sure to check out their YouTube channel. Liking and subscribing will help you stay updated with their latest content and support their work.
Okay, you had the robot, so you know what to do. We'll look at this paper next time in more detail. Hopefully turn it into a better visualization, something interactive, especially if we can grab the data of the raw data that was used for the paper. Apparently it's meant to be public domain. So go check out the tools discussed these two today. All the links should be in the chat or the comments or the description of the video. And let me know if there's any questions. There's no questions in the chat. I might call it a day. We'll continue next time. We will continue next time. Any questions? Check the website, ask your questions. Yeah, that's another recent edition. Go check this one out as well. It's quite good in terms of the usability on touchscreen, working on touchscreen. You can add up to 4 of these magnets. Play around with strength, angle. Oops. Yeah, so go check it out. Hopefully future tools will be as good as this one. I'll see you next time. Bye.